Alright, as we're doing this, I want to stress the importance of rewinding and watching parts over again and pausing as need be. But we are talking about the converse of triangle proportionality theorem, and we're also talking today about the corollary of two transversal proportionality, which you'll see at the bottom there. But let's focus on just the converse to start here. Let me get rid of that stuff. And what is the converse of the triangle proportionality theorem? Well, remember, converse is just when you switch the hypothesis and conclusion. You're switching the if and the then parts of the conditional statement. So now, this part comes first. If a line divides two sides of a triangle proportionally, then it, meaning that line MN, is parallel to the third side. Okay, so in other words, if you're going to tell me that KL is parallel to MN, you're first going to have to show me that the line divides the two sides proportionally. So we set up our proportions. 42 to 21 is 30 to 15. Are they proportional? We'll simplify those. Those come out both to be 2. So yes, we have proportionality. Okay, so how does that verify that? So we're going to say, yes, MN is parallel to KL, since the two sides were divided proportionally. And we want to get our writing skills here, and we want to really write all this out in complete sentences, clear ideas. Alright, so we're going to go down here, and in class we're going to do this as independent, then in pairs, then you're going to present on cardstock, and we'll do that tomorrow in class, or you can try it now on your own if you want to pause and do that. But in the meantime, we're going to continue down here, and we're going to put a corollary into our notes. Okay, and we want to write this down. We want the sketch too. Corollary just means that it came from the triangle proportionality. It's kind of a side note, but it's still an important one. And I drew a red triangle there to show you what this has to do with what we were just learning. That red triangle is just like the triangle with a parallel line to one side that intersects the other two. Let me erase that, and let's just focus on what we have there in the diagram. Let's first make sure we understand the hypothesis here. We have 3 or more parallel lines. I see 3 parallel lines there. Okay. 2 transversals. Alright, that's correct. And so we are going to copy this down, and you can see here that if you take AC over CE, that is equal to BD over DF, and that's right there. That's the conclusion. Alright, so we're going to move on now to an example of this. Alright, this is in your textbook on page 483, and what is going on here? An artist used perspective to draw guidelines to help her sketch a row of parallel trees. Parallel. She then checked the drawing by measuring the distances between the trees. What is LN? So basically she's checking to make sure that they're parallel, because there should be proportionality between these parallel lines. And you also have transversal. Let's just look at that a little bit. Parallel lines, you can see here. There are 4 of them this time. And then we have 2 transversals. They're the dotted lines here. Now when you do this sketch, I don't think it's necessary to include the trees and such. Let's just make it more simple. Now I have a special way I can do that. I can actually write over top of it with my pen, and then I can make the drawing disappear. So I'm going to do that. I'm going to sketch everything that I need that's important. So we got the parallel lines, the transversals. These points are important that we have those. We need to know what these lengths are. 2.4, 1.4. I know it looks messy now, but as soon as I erase everything, it'll look fine. And we know that this is 2.6, and we have K, L, M, and N. And I think that's every bit of information that I need. Oh, the question, I will need that because that's going to disappear too. What is the distance from L to N? Alright? And we are able to assume that these are parallel. Okay, so let me change the background here. Here we go. Thank you for your patience. So this is kind of a sketch of what you should have in your notes as you do this. And what is LN? So I'm going to identify what I'm looking for. Here is L to N. From there to there. Okay. I think our proportions could be set up something like this, where I'm going to make a ratio of LN to KL. So there's two red ones, and then I can use on the other side for the other transversal, I'll use some purple. And if I'm going to do that on this side, I need to use the same corresponding parts here to here. And what really is happening here is we really don't even need that segment in the middle there, CM. It's really not even being used. We do need to know what the distance is all the way from B to D, and we can use the segment addition postulate by doing that. 1.4 plus 2.2, and that gives you 3.6. So we can label that total distance in purple. Make sure we're still on the paper here. All the way from B to D is 3.6. Okay, and so we're ready to set up our proportions, and we all know that looks like two fractions that are equal to each other. And there's many ways you can do this, but I'm going to do 3.6 is to 2.4 as ln. Make sure you see where I'm getting that from. ln is to 2.6. Okay? And then we are going to cross multiply. Put parentheses around that length, equal to 3.6 times 2.6, and use your handy dandy calculator to get that. Okay, and you get 9 36/100ths. And I'm going to make a shout out to the math lady right now, or Miss Math, because I know she would be very upset if she heard me calling these numbers as 3.6 and 2.6. Really, I should be saying 3 and 6/10 times 2 and 6/10 equals 9 and 36/100. So I apologize, Miss Math, and I will work on that, I promise. So on the left side, we're left with 2 and 4/10 times ln. I know there's a million other things I'm doing wrong that Miss Math would be upset with, but I'm working on it. Okay, and then we can divide both sides by 2.4. 2 and 4/10 is what I meant to say. On the left side, 2.2 and 4/10 over 2 and 4/10, that's equal to 1. So we can eliminate that. And on the right side, 9 and 36/100 divided by 2 and 4/10. And that will give us 3 and 9/10 of a centimeter. 3 and 9/10 of a centimeter. Units are important to give us context. And I think that pretty much is everything. I think we mentioned everything that we should mention in that. Let's try to find out what is the distance of LM and MN. LM and you try those on your own first. LM and MN. You can pause. Okay, so for LM, which is right here, I would set that up with a ratio to this, and that will be equal to this, correct? You can set up that ratio, and you would eventually get an answer of LM is equal to approximately 1.1 and 5/10 of a centimeter. Okay, and then be careful with MN. That's up here. Let's use a different color. Let's use the blue. MN right here. The easiest way to do this, I'm just going to tell you, is going to be to use the segment addition postulate that says that this segment here, this segment LM plus MN, they both have to add up to be LN, and we know LN from earlier, right? So to find MN, we're just going to subtract 3 and 9/10 minus 1 and 5/10, because that will give you MN. And we'll go over any questions you have tomorrow in class.